EricRKandel, The Disordered Mind, What Unusual Brains Tell Us About Ourselves. Step into the realm of the disordered mind and uncover the fascinating world of unusual brains and what they reveal about ourselves. In this book's summary of EricRKandel's captivating work, you will delve into the secrets of mental disorders like depression, schizophrenia, and dementia, and learn how these conditions teach us about the intricacies of the human brain. Discover how modern neuroscience leverages cutting-edge technology to study the genetic basis of such disorders, and examine brain activity patterns. From autism's incredible insights into the social wiring of our brains to the powerful impact of addiction on the brain's reward system, this book summary will take you on an enlightening journey into the depths of the human mind.
Understanding mental disorders. Mental disorders are physical changes in the brain that affect our thoughts, feelings, and behavior. Modern neuroscience has helped us learn about how the brain works through studying mental disorders. Everyone feels sad or anxious at times, but when these feelings interfere with daily activities, they may indicate a mental disorder. Mental disorders such as depression, schizophrenia, and dementia have physical bases in the brain and can result from genetic defects, environmental factors, or injury. Through studying mental disorders, we gain insights into how our brain processes information. The brain is composed of specialized nerve cells called neurons that communicate with each other through electrical signals and chemical neurotransmitters. In many mental disorders, certain networks of neurons become dysfunctional or hyperactive, which can lead to altered behavior. Modern neuroscience has developed tools for studying brain activity, such as brain imaging techniques like fMRI. By understanding the mechanisms behind mental disorders, neuroscience is shedding light on how the healthy brain functions and how we can treat mental illnesses. The social nature of autism. Our brain's social wiring allows us to predict and understand others' behavior. Autism, however, reveals the specifics of how parts of the brain don't develop well, primarily in emotion, language, communication, visual perception, and movement, leading to difficulties developing a theory of mind, communicating with others, and recognizing human faces and movement. The condition affects a person's social and communication skills, leading to difficulties in reading other people's thoughts and emotions, responding appropriately, and picking up language early in life. Autistic children also have a strong preference for being alone and repetitive behavior, which often leads them to acquire savant-like skills. Using autistic children, we've managed to investigate the social brain's specialized part that helps us process information about other humans. Understanding the link between emotions and mental disorders. Our emotions play a significant role in how we experience the world. They allow us to connect with others, recognize our desires, and make judgments beyond reason. However, when our emotional system goes through trouble, it can cause mood disorders like depression, PTSD, and anxiety. The key takeaway in this summary is that mood disorders are linked to brain chemical imbalances in the emotional system, which influences our primal emotional responses. The limbic system regulates these emotional responses, and people with mental disorders tend to have overactive amygdalas and hypothalamuses, causing a chemical imbalance in the limbic system. The high cortisol levels in people with mental illness are linked to a change in sleep, energy, and appetite. Additionally, people with depression and anxiety have lower levels of the neurotransmitter serotonin in their brain. Schizophrenia, understanding the brain disorder. Schizophrenia is a widely stigmatized mental disorder that affects various brain regions, causing dramatic effects on an individual's thinking and behavior. Apart from visual and auditory hallucinations and paranoid delusions, it also causes social withdrawal, lack of motivation, and memory problems. Genetic factors such as the overexpression of the C4 gene and excess dopamine in the brain play a crucial role in the disorder. Schizophrenia causes excess synaptic pruning during adolescence, which triggers dramatic structural changes in the brain, particularly in the prefrontal cortex and hippocampus, leading to improper development. The disorder also has an intriguing connection with creativity, and it is speculated that mental disorders may fuel creativity by lifting constraints and inhibitions on our thinking and granting us broader access to our unconscious. The story of HM and the two memory systems. Henry Mollaison's case has provided valuable insights into the two memory systems of the brain. In a bid to cure his epilepsy, doctors removed the scarred parts of his brain, which included the hippocampus, a crucial component of the explicit memory system. While HM could recall events from his past, he could not form new memories. Researchers discovered that the brain has two memory systems, explicit and implicit, with the latter responsible for retaining learned motor tasks. Alzheimer's and dementia affect the explicit memory system, causing a slow but steady erosion of memories. Proteins are the culprits, with abnormal folding leading to the formation of clumps known as prion. These misfolded proteins lead to a loss of neuronal connectivity and eventually, cell death. However, the discovery of prion offers hope for the treatment of memory disorders. Decoding Parkinson's disease. Parkinson's disease is caused by misfolding alpha-synuclein proteins, which obstruct the dopamine-producing neurons in the substantia nigra. This lack of dopamine disrupts the normal functioning of the signal loop, resulting in a characteristic tremor and limited range of movement. Parkinson's disease reveals the role of brain chemicals in movement and was first described in 1817 by a British doctor of the same name. Addiction and the brain. Addiction is a chronic disease that fundamentally changes the brain's reward system by hijacking the systems involved in pleasure, emotions, and behavior. This results in the loss of willpower, making it difficult to quit habits that release the feel-good chemical dopamine. The key message here is that the brain's reward system associates pleasurable experiences not only with the drug itself but also with the places, people, and music that go with it. This means that addiction is a chronic disease, with high relapse rates among recovered addicts. Sex, gender, and brain development. Humans show a great range in gender behavior, but male and female brains do have subtle structural and molecular differences. Our sex and gender identity also express themselves in the brain. This anatomical development starts in the uterus, and due to various factors, there are many variations in sex and gender identity. Gender roles are pervasive in modern society across cultures. However, neuroscientists have discovered that male and female brains do have slight structural and molecular differences, even if they are not binary in nature. Thus, while humans show a wide range and variety in gender behavior, sex and gender identity express themselves in the brain. The article emphasizes that anatomical sex, gonadal sex, and chromosomal sex are distinct concepts. Anatomical sex is determined by external genitalia. Gonadal sex is determined by internal genitalia, while chromosomal sex refers to our sex chromosomes. However, disruptions or variations may occur in the development of these characteristics, and they may not correspond to a person's gender identity. Hormones released during specific times of development may influence gender-specific behavior patterns such as aggression and mating. This anatomical development starts in the uterus around week 6 or 7. If the fetus has a Y chromosome, testosterone initiates the formation of testes, releasing as much testosterone as during puberty. If no Y chromosome is present, the fetus develops female anatomy, and estrogen influences the development of gender-specific brain patterns. Overall, the article reiterates that sex and gender identity are not synonymous and that complex factors influence and shape them. The development of our bodies and brains allows for many variations in sex and gender identity. Consciousness unraveled. Consciousness is one of the most intriguing mental states produced by the brain. It refers to the ability to be aware of our mental processes as they happen. Neuroscience is gradually revealing how our brain produces consciousness. Our level of consciousness varies with the level of brain activity, modulated by a region in the upper part of the brain stem. Neuroscientists use brain imaging to identify brain areas involved in mental experiences and support the theory of the global workspace, which argues that unconscious processes are involved in the initial processing of sensory information. When we focus our attention on a piece of information, it becomes available in the conscious global workspace. Neuroscience, in collaboration with psychology, psychiatry, and biology, could unveil the secrets of this captivating mental feature of the brain.
In the disordered mind, you have discovered the invaluable contributions mental disorders provide to the understanding of normal brain functioning. By examining the genetic basis, brain activity patterns, and the effects of conditions like autism, mood disorders, and schizophrenia, we gain a broader perspective on the human brain's complex network and its underlying processes. Additionally, you've encountered the captivating world of addiction, its impact on the brain's reward system, and the mysterious relationship between sex, gender, and cognitive function. Finally, explore the fascinating, enigmatic puzzle of consciousness and the cutting-edge theories attempting to unravel its mysteries. Overall, EricRKandel's work serves as a poignant reminder that through studying the disordered mind, we can unlock the secrets of the healthy brain.